Today in Math 20, we're going to talk about the real numbers, real numbers, the number system. Not really the place value number system, but just what kind of numbers, categories of numbers. So the most basic category of numbers are, are what we call natural or counting numbers. So natural / counting. And those numbers are 1, 2, 3, 4, ... Because if you were going to count up the people in the classroom, you wouldn't go 0. You wouldn't start with 0. No, no one counts for 0. You wouldn't say 1.5. So things that occur in nature are whole numbers. Well, actually, these are whole, but these are actually natural or counting numbers. We have another category called whole numbers. So the reason why I'm drawing a box within a box is because whole numbers include 0, 0, 1, 2, 3. So notice that the whole numbers start at 0. The only difference between whole numbers and natural numbers is 0. So I like to say 0, it's a whole lot of nothing. Get it? Whole. Because it's a whole number. So the reason why the natural numbers is inside the box that is whole numbers is because the natural numbers are all included. Okay? After whole numbers, we're going to talk about integers. And we're going to be doing a lot with integers. Integers include all the whole numbers, all the natural numbers, and their opposites. So it goes back to infinity, -3, -2, -1, 0, 1, 2, 3. So integers, we call them the whole numbers and all of their opposites. Does that make sense so far? Integers, okay. The next group, which all of these numbers are a part of, are the rational numbers. Yes, whole numbers and their opposites. Yes, the negatives. Okay, so rational numbers, the root word of rational is ratio. And ratio reminds us that we can have a number divided by another number. It's a comparison of two numbers using division. So basically, all rational numbers can be written as fractions. Now, you have two kinds of fractions. You have regular, a proper fraction, 1/2. What is 1/2 equal to as a decimal? 0.5. So we call this a terminating decimal. Because why do you think I call it a terminating decimal? It terminates, right? If you were to divide 2 into 1, you would get 0.5 and it wouldn't be repeating. The opposite of a terminating decimal is a repeating decimal. So 1/3 is equal to what? Yeah, 0.3 repeating. So instead of that being a terminating decimal, we call it a repeating decimal. And remember that we use this bar. It's called bar notation. Bar notation is what we use if we have a repeating decimal, because we can't repeat it for infinity, right? So all rational numbers can be written as fractions. How would I write the number 4? Could I write the number 4 as a fraction? 4 over 1. There, I made 4 into a ratio, into basically a fraction. What about this number, the square root of 25? What would that be equal to? 5. And again, that's going to be a rational number because we could always put it over 1. Realize that 4 over 1 could also be the same thing. Isn't that also 8 over 2? Yeah, 8 divided by 2. So what I'm saying is we can continue to just write it as a ratio. They're equal to each other. Okay, the opposite of rational is going to be, what sounds like the opposite of rational? Yes, irrational. So irrational numbers, can you think of what's the most famous irrational number that we've talked about in this class? It's actually pi. Okay, because pi is approximately 3.14159 6, 5, okay, dot, 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 dot. The point of the dot, dot, dot is I cannot use the bar notation, meaning there's no pattern of repetition to that number. So that's why we call it irrational. It's not a repeating decimal. It's not a terminating decimal. It doesn't end, and it doesn't have a pattern of repetition. Some other numbers that we found were the square root of 5. Remember how square root of 5 is not, 5 is not a perfect square. When we were doing the Pythagorean theorem, we were talking about square roots. And what would happen if I took the square root of 5? I would get what kind of number? I would get a decimal, exactly. So let's look at what the square root of 5 is. Second square root, 5. Okay, I get this decimal, and again, this is not a repeating decimal. It's not a terminating decimal. There should be a dot, 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 dot at the end, but it's not going to have the same pattern. Even though we're going to repeat digits, they're not going to have a pattern of repetition. So we say the square root of 5 is approximately 2 let's round it to the nearest hundredths place. Rounded to the nearest hundredths. Who can tell me what would you round it off to if you rounded it to the nearest hundredths? 2.24. And why did we round that 3 up to a 4? Because of the 6. So hundredths place is 2 decimal places, right? And we're rounding this off. I'm using this squiggly equal sign right here to mean approximate, yes. And I don't use a straight equal sign because it's because it's rounded off. I'm losing some value or possibly gaining some value depending on if I round up or down. These are 2 examples of irrational numbers. What's that? So this is its own separate category. The opposite of rational is irrational, but together these 2 groups make up the real numbers. So together they are real. Okay. Now somebody asked me that you made the comment that all numbers are real, and I will say that when you get to your advanced math classes, you will learn about, I'm just needing to push this up a little bit higher, you'll learn about I, and I'll just throw it out there, I is equal to the square root of -1. This is what's called an imaginary number. Now the only reason why I bring up I is so that I can tell you a little tiny math joke, okay? So you have I hanging out with his buddy Pi, okay? And I says to Pi, be rational. And Pi, what do you think Pi says back to I? Get real. All right. So when you get to your more advanced math classes, you'll learn more about I. But just realize, just like you said, I is imaginary, just like when your kids have imaginary friends. They're not real, okay? But all the other numbers are real, and we're going to focus on the real numbers. Okay, so that is -1's not real? Well, actually, the reason... No, it's the square root. And we could talk about why in just a second, but if you think about this for a minute, if I square 5, what do I get? Square negative. Oh, we haven't even talked about negatives yet, so we can't really talk about this yet. All right, we'll get back to that. I'm just throwing that out there for now. Let's have you guys try the activity on this now.